Good morning, everyone, and welcome to our first day of MCA review. We're going to start this unit by reviewing scientific notation. So ignore this little question mark in the middle of our screen. I'm not sure how to get it off the screen, so we're just going to look past it. So reviewing scientific notation, well, a number is written in scientific notation if it has the form c times 10 to the nth power, where c is greater than or equal to 1, c is less than 10, and n is an integer. Now an integer is a counting number. So n has to be a number. In standard form, we have numbers that are big, like 325,000. In scientific notation, that's written as 3.25 times 10 to the fifth. Or we have 0.0005, or 5 times 10 to the negative fourth. Now when we have positive exponents, that's when we have big numbers. When we have negative exponents, that's when we have small numbers. So let's practice some of these. We have standard form and scientific notation here. So what we're going to do when we're trying to write this in scientific notation is we're going to put a little decimal point at the end of our number. Since this is a big number, what I'm going to do is count up. So 1, 2, 3, 4, 5. Now I'm going to go right to the number before, or the first number that I see as I read the number. So that's right behind the 4, because I know I need it to be between 1 and 10. So now if I put my decimal point there, it has 4.05. And we went 1, 2, 3, 4, 5 spaces, so times 10 to the fifth power. Here if I put my decimal point at the back, then I'm going 1, 2, 3, 4, 5, 6. So I get 6.31 times 10 to the sixth power, because we did 6 jumps. Now when we have it in scientific notation, but they want us to write it in standard form, we got to start with our number. Well, that's 7. Now it says times 10 to the second power. So we're going to imagine there's a decimal point here, and we're going to go back 2 spaces. So 1, 2. Put a decimal point there. Then I'm going to add these zeros in our spaces, so this number is 700. Here we have 3.484 times 10 to the eighth. So I'm going to go back 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8 spaces. And I'm going to fill the empty spaces with zeros. Now, if I put our commas in, we have a big number, 348,400,000. Here I'm going to go to the first number that I see as I read it, so that's going to be 7. So I'm going 1, 2, 3, 4, 5, 6, 7. So 7.2. I go all the way back until the last number that I see. So 009 times 10 to the seventh power. This one we have to write 5.01 times 10 to the sixth, so we're going back 1, 2, 3, 4, 5, 6 spaces. So what I'm left with is 5,010,000. Here we have small numbers. These are going to be less than 1. So this time we're going to use negative exponents. So again, the same thing. I'm going to move my decimal point to in front of the first number. This one is 5, so I'm going to move it 1, 2, 3, 4, 5 spaces. So I'm going to have 5 times 10. Now because it's a small number, I'm going to put a negative exponent. We moved it 5 spaces. Here I'm moving it 1, 2, 3, 4, 5, 6, 7, right behind the 6. So I get 6.301 times 10 to the negative 6th power. This time I'm going to write a 7, but now it has a negative 2. So what we need to do is imagine there's a decimal point behind the 7. But now if it's a negative 2, we're going backwards. So 1, 2. I'm going to fill the empty spaces with 0. And we get 0.07. Here I'm going to write 3.106 and move it forward 8 spaces. So 1, 2, 3, 4, 5, 6, 7, 8. Fill these with 0, 0, 0, 0, 0, 0, and 0. That's a very small number. Here, 5.4. This time we're moving it 6 spaces. 1, 2, 3, 4, 5, 6. 0, 0, 0, 0, and 0. Last one. 1, 2, 3, 4, 5, 6. Except we're not going to move it that far. We're only going to move it in front of the 8. So we have 8.9 times 10 to the 1, 2, 3, 4, 5 negative 5th place. Alright, multiplying numbers in scientific notation. So what we need to do here is multiply what we have. So the first thing I see is 6.1 and 2.3. So I'm going to multiply 6.1 times 2.3. When I do that, the answer that I get is 14.03. So I see one that's 14.03. That's C. So I know that that's a possibility. But now I need to multiply my exponents. Now when I'm multiplying exponents, I'm going to add them. So my exponents are negative 9. Now I'm going to add 3. So when I add those together, what I get then is a negative 6. So right now we have 14.03 times 10 to the negative 6th. But what I need to remember, this does say the same thing as C, but what I need to remember is that a scientific notation number has to be between 1 and 10. So this 14 is not between 1 and 10. What we need to do is move the decimal point one more space in front. So what it's going to change to is 1.403 times 10. We moved it one more space in front, so it would be to the negative 5th power. So our answer here is A. Next one, dividing numbers in scientific notation. So again, we're going to divide the front numbers and then divide the exponents. So if I divide the front numbers, I got 1.728 divided by 5.4. That gives me 0.32. times 10 to the, now when we divide exponents we have to subtract them, so 6 minus 8, that gives me a negative 2, so it'd be 10 to the negative 2. So none of those answers match up with what we have. That's because this 0.32 needs to be between 1 and 0. So to make it between 1 and 0, all I have to do is move the decimal point 1 space over to make it 3.2. Now if I moved it one more space backwards, that's going to change it, our 10 to the negative 3 power. So 3.2 times 10 to the negative 3 is going to give me C. Last one, which list shows the numbers in order from least to greatest? So, well, if we look at the first one, we see negative 2, and all the rest of them are negative 3s. So, I know that negative 2 in any case is going to be bigger than negative 3s. So I can cross off the A one because negative 2 is not going to be bigger than negative 3. Now we have 3.5 times 10 to the negative 3. 3.5 times 10 to the negative 3. That is 0.0035. 5.3 times 10 to the negative 3 is 0.0053. So as of now, I know that 0.0035 is less than 0.0053. So now we have to look at the next number. Ooh, excuse me. The next number for D is the same thing as was before, which would be 0.0035. Now I know that number is less than 0.0053, so I know that it can't be D because it has to go from least to greatest. C goes 5.3, so it's 0.0053. That's C. So it could still be C. B goes 0.0035, then it goes to 0.035, which is still okay because that's going up. But then what B does is they go back to 0.0053. So that's B, and I know that it can't be that. So I know that it has to be C.